Hello everyone. So today I'm going to talk about Spring Cloud Stream. First, we'll have a quick introduction or quick overview of what exactly Spring Cloud Stream is, and later we are going to do a live coding or live practice session on how we can implement Spring Cloud Stream in our project and how simple it is to do. So let's begin. So let's just first understand the basic definition of Spring Cloud Stream. So Spring Cloud Stream is a binding framework which binds your code to the destination. What it means is you just need to write your business code, your functional code, and provide the destination as the dependency. And Spring Cloud Stream will take care of the rest. It will bind your functional code to the destination that you have provided. It is that simple. Let's move. So Spring Cloud Stream is a framework for building highly scalable event-driven microservices. So by highly scalable, it means that you can create multiple instances of your microservices and scale it across. And event-driven microservices means that the data across your microservices will flow by the trigger of an event, and we'll see later how exactly it happens. So these are the event-driven microservices connected with shared messaging systems like Kafka, RabbitMQ, and Google PubSub. So as mentioned above, you have your functional code like you have your microservices and you have your destination or your broker like Kafka, RabbitMQ, Google PubSub. So Spring Cloud Stream will bind your microservice code or your business logic to this destination, or like one of this broker. It can be Kafka, RabbitMQ, Google PubSub, and you don't need to do anything. You just write code, provide the dependency of broker, that's it. So let's move ahead. We can produce, process, consume data stream with any message broker, either it be Kafka, RabbitMQ, without much configuration. This is a very important point over here, because as a developer we should just care about writing the business logic, writing our business code, and not what our destination is or not what our message broker is. Because today it might be Kafka, tomorrow it can be Google PubSub, today it is RabbitMQ, tomorrow it might be Kafka, right? So the broker can keep on changing, right? So based on that, we should not modify our code. There should not be any changes of in our code if we are moving from one broker to another. So that is what it says over here. We can produce, process, consume data stream. So that is a separate part with any message broker, either it be Kafka, RabbitMQ, or Google PubSub. And there is no configuration or very little configuration that will be required when you use Spring Cloud Stream. So let's move to the next one. The producer, processor, consumer is simplified using Java 8's functional interface. So before moving into this, let's understand what are the normal scenarios or what are the normal use cases that we have in our application. So there might be three major use cases, like you either take in the input, or you either return the output, or you take the input, process it, and return the output, right? These are the three scenarios, the most of the scenarios that we have in any application, right? So if you are taking the input, that means it is an consumer. If you are returning an output, that means it is an supplier. And if you are taking in an input and doing some processing and returning an output, that is something processor, right? So in Java 8 functional interfaces, this is the exact thing that they have done. They have written these three interfaces called function, consumer, and supplier. So as I said, if you want to just produce the data, you can implement supplier. If you just want to consume a data, you can use consumer. If you want to take in an input, process it, and return it as output, then you can use function interface, right? So many of the framework takes advantage of these interfaces in understanding what exactly the developer wants to do. So similarly, in Spring Cloud Stream, if we take an example of Kafka, whenever you're going to write supplier, as your bean, or you're going to provide the implementation of the supplier as the bean, Spring Cloud Stream is going to translate it to a Kafka producer. When you are going to return consumer as your bean, Spring Cloud Stream is going to translate it to Kafka consumer. And similarly, when you are going to return function as a bean, Spring Cloud Stream will translate it to Kafka processor. So you just write your supplier, consumer, function, and Spring Cloud Stream know what exactly you are writing, whether you are writing a producer, consumer, or processor. Let's move. Normally, when we use message broker for passing the messages between two applications, developer is responsible for the message channel creation or serialization, deserialization, type conversion, right? Which is not a good thing, because when you're moving your data between two applications using a message broker, there are a lot of configurations that you need to do, right? You have to create the channel, you have to do serialization, you have to do deserialization, which is specific to that particular broker. So if tomorrow you change the broker, you need to change the code which is specific to all these things, right? Serialization, deserialization, type conversion, channel creation, which is not a good thing, because if you move to a better broker tomorrow, if you find a better broker tomorrow, and if you want to move to that, you need to change all these things. Although as a developer you should only be concerned about your business code, right? So Spring Cloud Stream solves this. Spring Cloud Streams take care of serialization, deserialization. It assumes configuration, as we know that Spring is an opinionated framework. Okay, so what it does is, if you don't provide your opinion, okay, that this is the configuration, Spring is going to have its own opinion, or it is going to assume certain configuration. So if you provide the configuration good enough, else Spring is going to assume it, right? Because Spring is an opinionated framework. It will create topics, right? Similarly, to the configuration, if you don't provide a topic name, Spring is going to assume the topic name and it is going to create it. How exactly it does that, we are going to see it. How it assumes what should be the topic name based on the method name, we'll see it later when we are doing the live coding. So it does that so that developer can totally focus on the business logic and did not worry about the infrastructure. So developer just writes the business logic, and all this serialization, deserialization, configuration, all this boilerplate code is taken away, and Spring Cloud Stream manages it. So you don't need to worry about that. Let's move to the next slide. So this is the demo application that we are going to create when we do our coding. So we are just going to write producer, consumer, and processor. That's it. Okay, and we are going to add the dependency as Kafka, and you will see how smoothly everything happens. You don't need to do anything else. You just write your producer, your processor, and your consumer. That's it. Everything else will be taken care by the Spring Cloud Stream. So when I say producer, processor, consumer, we are going to return the bean of type supplier, consumer, and function, right? So this producer will produce the data onto one Kafka topic, processor will consume from that Kafka topic, processor will produce the data onto another Kafka topic, and there is a consumer that is going to subscribe from that Kafka topic. And tomorrow, if you want to remove Kafka from here and add Google pops up, your producer, consumer, and processor code remains as it is. Okay, you just remove the dependency of Kafka, add the dependency of Google pops up, and everything remains same. Okay, so now let's move on to our live coding. So let's start with coding now. So before that, let us understand what we are going to do. So in example 1, we are going to create this flow, but let us look in detail what exactly we are going to do. So in the first example, I'll keep it very simple. I'm just going to write a processor. So processor means, as you know, that it's function, right? So I'm going to write a function which is going to take input, convert it to an uppercase, and produce an output. Okay, that is the only thing that I'm going to write. And when I write the code, you can see that's the only thing, and it's very simple. For producer and consumer part, for example 1, I'm just going to use Kafka console producer and Kafka console consumer. Okay, and in the next example, we will write our own producer and own consumer. Okay, so to begin with, let's keep it simple. First, we'll write a processor, takes input, convert it to uppercase, produces output. So this Kafka console producer, using this Kafka console producer, we are going to generate a data, publish onto an Kafka topic. What that topic is, we'll see it later. And this processor is going to subscribe to this Kafka topic, gets the data, convert it to uppercase, and publish it on to next Kafka topic, to which we are going to have a Kafka console consumer subscribed, which is going to pick up that data. Okay, so let's begin with our coding part. Okay, I'll create a new project. I'm using a Spring Assistant to create a new project. You can also use a Spring Initializer website and do it from there. So let me write a group ID now. So I'll name it com.example.spring.cloud, and I'll name my artifact ID as Spring Cloud Stream Tutorial. Okay. It will be an Maven project. I'll use JDK 8 version. For the project name, I will just keep it same, and demo for Spring Cloud Stream, and everything else I'll keep the same. Let's just create the project. We have to select Spring Cloud Messaging Cloud Stream, and I'll select Kafka, and let's just keep everything same and click on finish. Okay, so till the time the project is getting loaded, as we know that we are using our destination as Kafka, right? So we need to start Kafka in background, right? So we need to do that. We need to start our Zookeeper. We need to start a Kafka server. So let's do that first before even starting our coding. Okay, so first thing is I'm going to start the Zookeeper. So these are all basic things, you can refer to any Kafka tutorial and on how to do this. So first I'll start my Zookeeper. So my Zookeeper is up and running now. Next I'll start my Kafka server. So let my Kafka server start. You can see the Kafka server is also started. So my Zookeeper is started, my Kafka server is started. So the basic things that are needed to run my applications are in place. Now let's just write a very simple application. Click function. If you remember, in the presentation I told that if you are going to write a processor, we need to write a Java 8 function, right, which is going to take input as string and also return output as string. This is going to do uppercase of the data that we are going to provide. So I'm just going to say data dot to uppercase. Okay, and the most important thing, we have to return this as bean. That's it. We have written our processor. It is that simple. Okay, what we have done is we have written a lambda function that basically implements this function. If you are aware of this in Java 8, let me just open this. So basically by providing lambda function, we are implementing this apply method. Okay, which takes in an input and returns an output. Okay, and our input and output are both string. So we have implemented that function using our lambda function, and this function we are returning it as bean. So simply this function is going to take an input as a data, convert it to uppercase and return it as output. That's it. Now and if you will see, I've just written this line of code, and in my pom.xml I have binder Kafka. So if you're having RabbitMQ, you'll have a separate binder. If you are having Google PubSub, you'll have a separate binder for that. So only two things: this binder and this code. This is our processor code. So if you go back to our PPT, so I have written this part. I have written a function, right? All these things I have not done yet. For, as I said, for console producer and console consumer will be used as part of this example. Okay, so let's just start our application now. So now you might be wondering, I have never mentioned any two uppercase until now, right? Basically any topic name, and you have seen over here that the topic name is something like this: two uppercase in zero, two uppercase out zero. So how it is doing that? So if you will see over here, what it does is it takes the name of the method. Okay, and if you are subscribing to a particular topic, that topic will be named as two uppercase underscore in, and the publishing to a particular topic. So when this processor publish to a particular topic, that topic is named as two uppercase underscore out. Okay, so if you will see over here, there is an two uppercase in, right? So that is the topic name that it has created on its own. As I told that if we don't provide any topic name, it is going to assume the configuration. Obviously in our actual application we'll have our own topics created onto Kafka. So how we can configure that we'll see in our next example, but for now it's very simple. I have not done anything. Spring Cloud Stream has created topic name on its own, like both topics, like from where I'm going to consume the data and from and to where this function is going to publish the data. Okay, so now let's just try it out, right? So to do that, as I said, I'm going to use console producer and console consumer. So let me just start my console producer first. So if you'll see over here, I'm using topic as two uppercase hyphen in, right? That's what is over here. Now let me start the consumer. Okay, so both my producer and consumer are up now. Let me start streaming the data. I'll just put them one below the other so you are able to see it. So let me just type in something in lowercase. You can see over here it is converted to uppercase, right? Let me test one more thing. It's working. Right, so let's just go back to the flow. What exactly is happening? So this part is this Kafka console producer. Okay, this consumer is this Kafka console consumer. Okay, that is both are the console producer and console consumer that is already provided by Kafka. This portion is the one that we have written in our code, the simple processor that we have written. That's it. And other things of creating the topic and everything is done by Spring Cloud Stream. We don't have to do anything. It is that simple. Okay, so this was a basic introduction or a basic example. In the next one, we will see how exactly we can write our own producer, consumer, how we can configure the topic names and all those things. Thank you.